Hey, good afternoon, everybody. Welcome to another UE Systems webinar. Today, we've got John Archer, who is our regional manager in the Southeast. So if you are in the Florida, Georgia, Alabama, Mississippi area, you probably know John or have seen emails from him or phone calls or had him into your plant. But everybody else from around the country, that's who's going to be presenting today. And you've probably maybe seen him at some trade shows and things like that. But he's got a lot of great information to share today about enhancing electrical safety and reliability. Obviously going to be talking a lot about how we can do that with ultrasound, of course, our bread and butter here at UE Systems, but also how infrared plays a part and how the two technologies really can come together to give you just the best electrical safety program that you can have. So exciting conversation to be had today. Before we dive into that, just have to give a quick little plug for our conference, Leading Reliability. We've got that coming up in basically 2 months now in Clearwater Beach, Florida. It's a fantastic week of workshops and presentations. The majority of the content being provided by actual end users, customers that are just like yourselves out there using different technologies, whether it be vibration or ultrasound, infrared, motion amplification, all the things, and different struggles that folks have had and how they've overcome them to improve their reliability programs. So it's a lot of actual, real life case studies and learning from your peers. And it's just a beautiful location, especially this time of year, to be down in Clearwater Beach. So if it's not something you've taken a look at, leadingreliability.com is the website, and just think it's a great week, and everybody that attends, I think, would attest to that as well. So just a little pitch for that. And then just typical little housekeeping notes. So we are recording this, and we will put it up on our YouTube site this afternoon. If you haven't been to our YouTube channel, we have a ton of resources over there, including all of our previous webinars that we've recorded. So check that out. And then we also are going to do some poll questions throughout the webinar today, just an opportunity to kind of get to know you guys a little bit better and where you all are with using the different types of technology, etc. So we'd love your participation in those. Help break it up a little bit, keep everybody awake during the lunch hour here. And then we of course also welcome questions, so you can type those into the little questions box. I'll be keeping an eye on those throughout the webinar, and then we'll of course have time to do some Q&A at the end. And then if we don't get to your question, or if it's a question that's a little better suited to be answered specific to your facility and things like that, we'll 100% get in touch with you guys after this webinar is concluded. And always like to do a little reminder that we are doing this live. We do like to come to you guys live with these, but it just gives the potential for any Wi-Fi outages or audio issues, dogs barking, all the things. So just bear with us, but hopefully we'll get through this smoothly. So with that, I am going to toss it over to my colleague, John, and John will let you take it away.
Perfect. Thank you for that, Maureen. So, yep, I'm based out of Central Alabama, so I cover the Southeast in general, but I'm always happy to come out and support your plants. Anyone that is interested in the materials from this, please let us know. I'm always happy to share that as well. One note, unfortunately, I was not able to get the sounds that I built into this to be able to play for us today. So I'll be as descriptive as I can, but if you have any specific questions on the examples that I have, please get us your information. I can actually send you those files directly as a reference. But the goal of today, kind of outlined here, just generally talking about why we would like to use ultrasound for an electrical inspection, especially in a safety aspect, what the foundations of that looks like, what and where we would use ultrasound for inspection, what we can and cannot detect, because that's probably some of the most important information to begin with. And as far as between ultrasound and infrared, when to use which device, using them both together, the right applications, the right methods. And then I would like to show just a couple examples of reports and real life findings we've had out in the field. But before we move too much further into this, now that we have the outline of kind of my topics I'd like to talk about, the first thing I'd like to do is actually find out, everyone that's watching right now, who is actually doing their own inspections for energized equipment in-house versus having a provider come in and do it. And if you are doing it in-house, are you using ultrasound, infrared, or both technologies together?
Yeah, so I just launched that. So first one, we'll leave this up for just a couple seconds here. Just curious who here is using ultrasound or infrared or both or neither for your inspections. Looks like we've got a good majority are using both. We do have some folks that aren't using either, but hopefully after today that will change. So thank you guys for participating in that. And then the other question that John was alluding to there is just curious who, if you are doing electrical inspections, are you doing them in-house or are you having a service provider come in to do those? We're always curious how that plays out. And it looks like the majority, John, are doing them in-house. Well, now it's, as more people are voting, it's about a 70-30 split on that. So that's interesting. So thank you guys for playing along. And I'll close that out and John, let you get back to it.
Perfect. All right. So as far as for those of you that aren't using ultrasound for an electrical inspection, I guess one of the main things that you're probably looking for is, why? Why would we start doing this? If we're already in compliance, if we're already, having infrared inspections done at least annually, ideally more often than that, but why include ultrasound? So it's the idea of it is, as the topic of this conversation, it's a holistic approach. There are things that ultrasound will be able to inspect for that infrared would not be able to pick up, and vice versa. One does not replace the other. They work together to have a more thorough and in-depth inspection. So what infrared is looking for is your resistance issues. So events that are going to create heat, whereas ultrasound is actually looking for the friction caused by these electrical anomalies. So things like an example of what infrared might miss, but ultrasound would complement and pick up would be something like a corona underneath 200,000 volts. That gives a very, very easy to detect and noticeable acoustic signal that we can pick up and then verify. So just using both of them together in that instance will help find all of the different forms of electrical anomalies that we're looking for, partial discharge. The other point too is beyond making sure that we are finding everything that we're looking for and not having to re-inspect multiple times, is that it really makes it safer. Just like in, I'm sure everyone's seen it, MCC rooms where there's a whole bunch of medium and high voltage equipment, and unfortunately not everything has a infrared window in it by standard design. So what that means is a lot of the stuff has to be open to have a proper inspection. And just like with ultrasound, we need that equipment to be energized to perform a proper inspection well. Personally, I would like to know that regardless of what PPE I'm wearing, if I'm about to have a very bad day opening up that cabinet to do an inspection. And that's where typically we start recommending ultrasound use. Being able to hear what is happening inside that cabinet before we open that plane and allow any sort of event to possibly happen that would make us have a very bad day after that. So it's the beginning point is the safety aspect. And I'll have some examples of that coming up. Now, I use the two different terms interchangeably there, electrical anomalies and partial discharge. In context for all of our reporting, we always are looking for different forms of partial discharge. So what that means to us in the ultrasound world is just a couple of these points right here. Really, partial discharge inspection is the observation, recording, analysis of high frequency emissions. So it's the sound emitted by these electrical events or anomalies. Now, once we actually take that sound and look at it and analyze it, we can actually determine if it is a form of partial discharge or if it actually might be a mechanical issue. So is it a tracking event happening inside this cabinet, or is it the nameplate vibrating on the door itself? Looking at the sound file, the signatures and the frequencies, we can actually determine between those. to the point we can also see if we have multiple events happening at the same time, such as a loose component that actually does have an arc happening within that cabinet, which would be a much more severe issue and require a different approach. Now, it typically does require the use of spectral analysis, further analyzation to determine these sounds and frequencies. And while that is a recommendation, we still have the option of, as this last point, either a quick go, no-go inspection of listen to the cabinet before it's opened, or actually taking sound recordings, bringing them back, analyzing them, and then doing further inspections. Clearly, the strong recommendation is recording sounds, bringing them back, and further analyzing them. And as I've pointed out once or twice, safety is the biggest thing. I would personally, being a husband and father, do everything I can to make sure that I go home every single day, especially when I'm working around energized equipment, regardless of the voltage. And that's where ultrasound being that first line defense, listening to the inside of a piece of equipment before it's opened, inspecting it from a very healthy distance before we close it, like outdoor energized equipment, switchyards, substations. It's all about safety. So that's going to be a huge topic throughout this presentation, is ways to use it in a safe manner. Now, with that being said, ultrasound is a great tool for addressing these safety challenges. And another point that I'll make as we go through this presentation, for those of you that have infrared experience, certification, lots of camera time, whatever it might be, a lot of the techniques, a lot of the methods, you'll see a lot of similarities there, which is really, really beneficial, in that if you have guys in your facility, or gals, that are already doing infrared inspection, it's a natural transition to picking up ultrasound equipment and using it. And this is a great example. We address a lot of the same issues. In the two pictures I have here, one with a traditional unit and one with an acoustic imager, we're able to overcome the challenge of fencing, barriers, to actually inspect substations. So we don't have to change our PPE requirements because we're not going beyond the gate. We don't have to have permits. If we were a service provider here, we wouldn't have to have an escort employee to get into this part of the facility. And just like with infrared, we have that option of inspecting from distance if we have the right pieces of equipment with us. And just as with fencing, gating, terrain obstruction, so outdoor power lines in the middle of nowhere, it's a lot easier to inspect them from a great distance. Really, we have the ability to go up to about 500 feet away on different assets and inspect them. So that really helps with some of the obstacles that we would face out in the field. Panel access is another one that we're able to overcome, as long as it is not a solid plate, airtight, watertight. Ultrasound will find a way to escape. So that's where we can listen to the outside of a panel and hear what is going on inside it. Also, because this is a non-contact, non-invasive inspection, that does change our approach, and it usually allows for a lot more flexibility on the inspection of energized equipment. Once again, we're not having to put on necessarily different levels of PPE requirements because we're not making that contact. So that can make the inspection faster and easier, and honestly more comfortable. As I said, it's a non-contact method. And then with that being said, the ultrasound range, one of our concerns is always, is the equipment energized or not? We're not necessarily concerned what is the voltage of it, other than for reporting. We can hear electrical events happening regardless of the minimum or maximum threshold of that piece of equipment. The only time we really need to know that is for the actual reporting side of it. So, it gives us a lot of assets that we can go out and inspect on a daily basis. So as far as, now that we know what we're doing and why we're including ultrasound, the foundation of a good inspection really relies on your technique. There are several different ways you can go about it. If you're inspecting from the air gap around a cabinet, that is definitely going to be a different technique that you would use than from a very large distance away, like at a tower or at a substation across from the fencing. So you have to, use the right technique or the right application. But in general, what we're looking for before we even go out to inspect this equipment is the equipment itself. Do you understand the range that your unit is capable of, the angle of your inspection? Does your device have the ability to record sound files? If so, do you have everything that you need for that? The next point that we want to make sure before we go out and do this inspection is, do we have everything we need to do this inspection? Do we have the right amount of time? Do we have the right PPE requirements, permits, whatever it might be? Because if we're not going to be methodical doing an inspection, taking our time and not rushing through it, then it's probably not the best time to do it to begin with. The last thing anyone would want to do is go out and do an inspection, give a piece of equipment a pass, and then actually miss an underlying fault that might be a hazard to someone down the road or to our operation in general. Another point of a good inspection foundation is making sure that we have everything set accordingly. So generally speaking, for ultrasound purposes, we always want to make sure that our sensitivity is adjusted accordingly, not only so that we can get a decibel on the screen, but also when we do record that sound file to bring it back and analyze it, we can actually break down what is going on. If that sensitivity is maxed out in recording sound files, chances are when we bring that back, we're not going to be able to analyze it, figure out what's going on, so we'd have to go back out and perform this inspection again. The other point that is always critical to keep in mind is very, very similar to infrared. What is the angle that you're inspecting from? In the same context of if you were inspecting an asset outside at a sharp angle, you could get a lot of reflected heat showing off of that. Solar load, same thing with sound. Sound loves, especially ultrasound, loves to reflect off of surfaces. So we generally try and make a head-on approach to whatever we're inspecting. If it's something that has a lot of curved surfaces, other pieces of equipment around it, that's things that we have to be mindful of and possibly change the angle that we're inspecting from. So just always be aware of reflected surfaces. And then not necessarily a requirement, but cannot recommend it strongly enough, is recording capability. I say not necessarily required because we can still do that go, no-go inspection. Is it, from the inspection outside, are we hearing anything or not? But if we do hear something at that point, if you can't record the sound file, you don't really know what's going on. You have to de-energize and do further inspection. Whereas if you can record that sound file, you know exactly what you're looking for. So if you are going to do that, have a piece of equipment dialed into the correct sensitivity, and I strongly recommend a 20+ second sound recording, because with a longer sample like that, that gives us the opportunity to pick up individual anomalies, such as something like arcing, where it's not a consistent rhythmic discharge, it's sporadic. With a longer file, we have a greater chance to get a full understanding of what event is occurring. And the most critical thing for ultrasound inspection is making sure that we are actually listening at the right station. So any ultra probe that's out there being used for an electrical inspection should always be centered at 40 kilohertz. There's no reason to move that around. So just before you even start sweeping, make sure your sensitivity is dialed in and your frequency is correct. And then the last point, might sound silly, but have to put it out there, is that yes, the equipment does have to be energized to inspect it. If there's no electrical current running, then there's no event happening. So just a critical point, make sure that what you're inspecting is actually energized. And then this video that I'm playing right now is just a good example of the speed. So going around the seam, we don't have to be going at a snail's pace, just a calm, steady sweep around it. Now that we know really kind of what the keys are that we're looking for in a good inspection, here are the things that can make a inspection go horribly wrong. And oftentimes, if you do make these mistakes, there's a chance that you'd have to reinspect either that asset or the area that you were doing. And these are easy to avoid mistakes, just keep them in mind. The biggest thing is your distance. It will always be tempting to get as close as possible because you're trying to hear what's going on inside there, but just leave a good 2 to 3 inch gap between the end of your device and whatever the seam is that you're inspecting. In this example that I'm going to play right now, unfortunately, I don't have a sound for this, but that is dragging all along the front of that cabinet. I'm making contact with something energized, which is in principle something I do not want to do at all. But you can kind of see it in this video, which I will pause for you right here. So I actually have my FFT and time waveform on display on this camera, and you can see impacting events on there from where that boot is contacting the cabinet. Now, if I had just done that one brief time, not actually drug it all the way across, I might have heard that crackling from that foam on the cabinet and thought, Was that possibly an electrical event? Was that tracking, that cracking? Was it something mechanical? So now, because I didn't leave a good healthy distance to inspect from, I'm going to be wasting a few minutes trying to hunt down a sound that doesn't actually exist inside that cabinet. So just be mindful of your distance that you're inspecting from. Once again, another small, silly one, but I'll be honest with you, I've done it myself. Make sure that you have a fully charged battery with your equipment. And if it's something like the device I have in my hand right now, this Ultra Pro 15,000, make sure you have an extra one. Last thing you want to do, especially in a hard to access area, is start your inspection, realize you have about 20 minutes of battery life, and you better be quick. Same thing for memory. Just make sure your card has plenty of memory on it. If you have backup ones, that they're actually on you. And as on the last slide, biggest thing about any good inspection that you're recording sound file is 40 kilohertz and your sensitivity dialed in appropriately. If you hear something and you're recording it, double check all your settings. Look at your frequency, look at your sensitivity, make sure the amplitude isn't excessively high, and then take that good clean sound file so you can inspect it properly. And if we are going through the time and effort to do a proper inspection, not rushing, taking good quality sound files, then it's a good idea to make some notes. You're hearing an event, look around the room. Are there dirty air filters stacked up in the corner of the room? Is there a box fan that should be in a dorm room actually blowing cool air into the bottom of a transformer? So now you know all the dirt from the floor is being blown up into this piece of equipment. General observations of the room, it might help explain some of the things that you are hearing within that piece of equipment. Also, follow-up procedures that might need to be done. The other part, and while you're looking around for observations of just general cleanliness, what else is in that room that could be making sounds? Is there an air handler unit that you can hear rattling? Well, if you can hear it in a low frequency, I can guarantee you it's making high frequency sounds. Are there motion sensors in the room that when you enter the room, you don't have to hit a switch, but the lights automatically come on? A lot of those are actually ultrasonic sensors. So things to be aware of, look around the room before you even start the inspection. Be aware of what may be creating other sounds. Another one that is very, very important is your wrist strap. It's built into the device. It is not a quick disconnect with any ultra probe. So the piece of equipment is not built to not have that attached to it, so you might as well use it on your wrist. The other part is that if you're not going to have it on your wrist and it's dangling around, there is always that snag hazard. It's going to make contact with something, you're going to be moving and it'll snatch it out of your hand, or you could damage another piece of equipment by yanking something. So just always have that wrist strap actually on. And then the other point too of, if we're doing electrical inspection, there are other factors you might want to consider. Are you able to document the temperature and the humidity of the room? If there's high humidity in an MCC room, that's definitely an issue. But really where we're looking for that is anything that's in a non-climate controlled environment. Humidity can play a factor, and it should be something that we're in consideration of. And then the last point, which is the first point previously, what is your distance and what is your field of view? From where you're inspecting, can your device actually make an accurate inspection? If you have a module in the front of your unit that's maximum distance is 50 to 60 feet and you're inspecting 100 feet away, you think you're having a great inspection, but you're just outside of your limitations. So just keep that in consideration of where you are as opposed to what equipment you're using. And just some quick examples of on the left and the center, good distance to have either with a scanning module or with that focusing cone, as opposed to on the right, far too close. And the example here is, we have this bolt that while I might barely be skimming past the seam, I come up to that bolt now, I make contact and either startle myself or collect bad data, especially if I'm recording from that point. So this is where it is important to have that healthy distance and inspecting 2 to 3 inches. Now here I do have 2 more videos, just 2 general recommendations for the inspection process. But before I get into this, I actually do have another poll question I'd like to ask. So for those of you that do have ultrasonic inspections going on, and honestly even infrared inspections, from the people that are out there doing the inspection and collecting the data for you, how many of your team members that are doing this are actually certified in ultrasound, infrared, or both?
All right, so I'm going to launch that one for you. So if you guys don't mind tossing in some answers here. Early results show about 55% have folks certified in both, so that's nice to see. And then, well, a decent chunk with neither, so that's always something to be thinking about. And a lot of folks certified in infrared for sure. So that's also good to see. We'll leave it just for a couple more seconds. We got about 60% participation. All right, cool. Thank you guys for playing along again.
Yeah, absolutely. So the reason I was asking, it's always a good idea to have people certified, because then not only are they qualified of knowing how to do the equipment, what to look for, but they have a better understanding of why they're doing these things. So if they do detect anomalies out in the field, they're more capable of handling it. But just something to keep in consideration. So the first video I'm going to play for you is this one on the left. It's the idea of, we're inside this MCC room, and we are going to inspect each energized piece of equipment that's on our list for the day. But the first thing I usually would like to do, especially in this example, it is a very, very large room. Doesn't look very wide, but it is very long. So sweeping the room, for those of you that have gone through any sort of equipment orientation or level 1 certification, we call it the gross define method. We're taking a large area and narrowing it down by checking our X and Y axis. And as we're sweeping over it, the source of sound would increase or decrease as we pass over it. So as I said, unfortunately, I don't have the sound file, but we did have an anomaly sound that we were detecting. So in sweeping left, right, up, down, we're actually able to walk straight to the source point of this sound. So sweeping left, we heard something, it kind of fades away, becoming more intense. All right, less intense, more intense. So now that we know the direction, we start closing the distance. And as we're closing the distance, we're going to continuously lower our sensitivity, so we have to be more in line and closer to the origin point. And looked far away from it just to make sure it wasn't a reflection. And in fact, there was a sound coming out of that cabinet. Took a recording, analyzed it further, and it was a benign sound, but just as an example of being able to walk straight to a source point. Now, the next video that I have for you is an example of an outdoor inspection. So clearly, once again, I'm in this video. I don't have the correct PPE, nor the permits, nor the escort to go beyond this fence, so I'm having to do the inspection outside of it. Because of this distance from my access point to where all the pieces of equipment are, I'm limited on what I can use. So in this one, I chose to use a waveform concentrator. Those of you that watch football, it will probably look fairly similar. But what it does, it gives us a very, very healthy inspection distance, about 220 feet or so, in a 5-degree field of view. So we're able to inspect everything within this yard without having to cross that plane. Now, the method is somewhat different. I'll go ahead and start this video. But biggest thing is, just like with any other inspection, make sure we're on 40 kilohertz and the sensitivity dialed in to where we actually can hear clearly. And instead of doing that broad sweeping, we're actually able to pinpoint each individual component. So here I'm looking at connections, the bushing of the transformer, anywhere where there could be something like tracking, arcing, or corona happening. And just able to slowly sweep. Now, because ultrasound is so incredibly directional, it's strongly recommended to, once you inspect one area, go ahead and move around. Now, you can't see it off screen here, but there is a further area in the yard with a few more transformers. So rather than just staying in one point inspecting the whole yard, kind of shift to where I have that direct line of sight. And then to verify that I don't have issues anywhere else, moving around to another side of that fencing, re-inspecting one more time each one of those components to make sure that nothing was missed. And once again, be methodical, take your time. If it's worth doing it right. So I think we get the idea. Take your time, sweep each individual piece, and try and inspect from at least 2 different angles if you cannot cross the barriers. And in this example, did not have any events that were detected. So great inspection and no anomalies found, which is the ideal situation. All right, so now that we've covered the foundations, what we're looking for as far as making a good inspection, mistakes to avoid, typically when we're using ultrasound, there are specific assets that we're looking for. As I said earlier, always needs to be energized, but typically the most common inspected piece of equipment are going to be dry transformers. Once again, the voltage is not a big concern except for the reporting side of it, so we can inspect medium, low, and high voltage. We can inspect oil field transformers. Specifically, what we'd be listening to is the bushing on top. So as in the image on the right, just make an inspection where the connection is on top, because we could hear something mechanically loose up there, or possibly damage to those ceramics rattling. We do have the ability to listen to the internal winding, but that is something that we don't typically recommend because that changes it from non-contact to a contact method. But just something to be aware of. We also typically look at switchgear, MCC buckets inside that room, load interrupters, VFD panels, soft start controllers. As you saw previously, substations are an easy one to inspect, as well as outdoor power lines. Typically, they're medium and high voltage that we would be inspecting. And once again, a lot of that, we're looking specifically for corona, but we can still inspect for tracking and arcing as well. Now that we've looked at kind of typically the piece of equipment we're looking at, on those pieces of equipment where we're looking to inspect. So while there are options for ultrasound inspection ports, typically, at least from the facilities I go to, that's not a common thing to have on equipment. But thankfully, the nature of ultrasound makes it where we can naturally have inspection points on most assets. What we're looking for is anywhere that airflow could be happening, that means sound can be escaping from. So typically panels around the seam of doors, the panel itself. In these two pictures, venting, any sort of air exchange, grates. If there are missing bolts, so now we have an open hole, that in itself is an ultrasound inspection port. Biggest thing to be aware of is there a fan running inside this piece of equipment or around you? And of course, we're absolutely not opening panels to make an ultrasound inspection, especially if you do hear an event happening inside of it. And if you are inspecting from an opening, we're not breaking the plane. So like an example would be, everyone has them constantly, probably have a couple lunch boxes sitting on them right now somewhere. The 480 lighting transformers that are in the shop next to the wall, we can inspect from that vent on the top, but we're absolutely not inserting any equipment into that or making contact. And the biggest thing about it, where I have these circles actually drawn on these two images, are I would strongly recommend inspecting from every point that you can. If in this example we have grading on the top and the bottom, I would inspect on both. For the reason being, in these specific examples, we did an inspection. We heard a very strong partial discharge sound coming from the top on this left picture. But then when we inspected from the bottom, we heard the same event, but much more muffled. It could have honestly been missed if someone had not been taking their time. So because once again, sound is very directional, we heard a stronger signal from the top. So definitely an issue going on, but that was also, we had a much better sound quality recording from the top than we would have from the bottom. And in the example on the right, we heard a moderate to fairly faint signal coming through from that bottom grate. When we inspected from the top, it was almost missed. So once again, if you have the option to inspect from the top and the bottom, do it. You might pick up something better from one than the other to make that recording easier, or you might actually miss it if you don't inspect from both points. And as you saw in that video at the beginning, the speed of inspection doesn't make it overly time consuming. And just some picture examples of using the design of an asset to create your own inspection points. So bolt holes, air exchanges, vents, grating, the seams themselves. All this can be used to hear inside this energized equipment. Now this is one where if you are commonly inspecting MCC rooms, do reach out. I had sound files attached to each one of these images, but we can send those to you separately afterwards. But these are probably the most typical things that can give you either false reads or that you just want to be incredibly mindful of beforehand. The first example I have on the left is the MCC, or not the MCC, the VFD station. This will always create a high pitch ultrasonic frequency. So just be aware that it's a natural harmonic of this equipment from the nature of it, but it can reflect off of other pieces of equipment. So do the visual inspection before you start sweeping the area. The example that I have here in the middle is be aware of especially fans. Here we have a fan in the room that if we were not aware of and been inspecting other pieces of equipment, there was actually a damaged blade inside of this fan that was rattling around rather aggressively. And if that had reflected off another piece of equipment, it actually could have been mistaken for tracking, possibly with mechanical looseness and tracking in that sound file, depending on how close we were. So once again, if I was listening to MCC bucket and I heard the sound coming out of it, I would be immediately concerned and inspect further, record it. But being aware that this fan was in there, go and inspect it first, get familiar with that sound, almost use it as a baseline for that room itself. Be aware that also, in this example, we had just come out of a shutdown and the fan was damaged and it had actually been inspected. So clearly either something was put back incorrectly or missed during the initial inspection. And then the last example I have here is be aware of room occupancy sensors. As I mentioned earlier, a vast majority of them out there in the field are ultrasonic based, and they will also create a high pitch frequency sound. Something to be aware of, that it is not coming from any of your energized equipment, it is the actual lighting itself. So now that we've covered all this, what we're inspecting, how we're inspecting it, good things and bad things to avoid, what we're actually looking for. I mentioned it earlier, but the specific forms of partial discharge that we are looking for is corona, tracking, arcing, and also looking for mechanical looseness. And I have a further breakdown of this later, but these are these very specific assets that or events that we're looking for, and they all have very specific signatures, both in sound and also when we're breaking down the files through spectral analysis. So what can't be detected? I always get these questions. I always like to make sure people are aware that just like with infrared, there are things that cannot be inspected. Through ultrasound, there are very specific issues that we do not look for. We will refer to other applications for it. So the first one is transient earth voltage, often just referred to as TV. While there are devices out there that are ultrasonic based to inspect for this, they are very specialized pieces of equipment and they are contact based. So I would never look for TEV through an ultra probe or an acoustic camera. And resistance issues, that's a big one. That's always going to be infrared. That's where using both together are going to give you a more holistic approach. One seeing what the other cannot, working together for the same end goal. Another thing is that we're not able to look into or listen into gas insulated equipment just from the design of it. It is not recommended. The only way that you would be able to do it would be a contact method, which once again, that would eliminate what we're trying to avoid here as far as changes to safety and PPE requirements. And then the last one, as I mentioned earlier, we cannot find partial discharge issues if the equipment is not energized. So it's always a critical thing. Be aware what is and is not energized when you're doing these inspections, which is where, for those of you that are not doing your inspections in-house, you're having a service provider come in, make sure that they are fully aware of what is and is not energized, just as you would try and have when they're doing an infrared scan, things on the heaviest load possible. You'd want to make sure as much equipment is energized so they can inspect everything at once. So most of these inspections I've shown you have been based around solely an ultra probe, traditional device, but I think everyone at this point has now seen acoustic imagers out on the market. So everyone that's watching, who here currently is either using some form of acoustic imager or has at least seen one in person?
Okay, sorry, I was responding to we've got some good questions people are sending in. Okay, so let's see here. We're doing the acoustic camera. I'm gonna launch this. So yeah, I'm just curious if you guys have seen these acoustic cameras out in the wild. Have you actually had a demo of one. Are you currently using one? Or, obviously not yet is also an answer. So let's see. It looks like it was pretty even split across all three options. So a lot of you have demoed them, a lot of you own them, and a lot of you haven't seen them yet. So it'll be cool, John, for you to kind of go through it now and show people what they may be missing, and those that are using them, just a reminder of the power of these acoustic imagers.
Yeah. So it is it's a fantastic tool. It definitely has that Star Trek feel to it, that we're converting a sound to a picture. But for those of you that aren't really familiar with them, the principle of it is that in this image on the right, we have a FLIR SI2 acoustic camera. So each one of those little pinholes that makes it look almost like your shower head, inside that hole is an MEM sensor, and they're in a very specific array, and the volume of them is what gives them their accuracy and their range. But each one is listening for these sounds, and in that array, they're mapped out specifically around that center hole, which is a camera lens, which is how it's able to create a cone that it's looking through and target where the sound is coming from and triangulate that onto the screen itself. So we're able to actually have that sound show up as a target. So in this example, a almost looks like a thermal target or a weather map, but that's actually a origin point of ultrasonic frequencies. So we're still looking for the same thing, corona tracking, arcing, mechanical looseness, but we just have a built-in computer basically on this camera that's doing the work for us. It's analyzing it, it's targeting it, while it's still going to show sources of ultrasound. The part of having the computer built into it is that it actually can understand if this sound is actually electrical based or not, which is where the big benefit comes in for field inspections. Now, just like with any other device, there are places that we would want to use it and places that we would not. Once again, the point I'm making it again, energized equipment, we do want to make sure that there's actually power running to this. Ideally, we want to have direct line of sight. So that would be things like substations, outdoor switchgear, energized yards, medium and high voltage cables, transformers outside. Once again, the bushing on top, the wiring running to it. Just like with an ultra probe, we're really not trying to inspect the winding inside it, because that would be a contact method. We're not looking to inspect gas insulated equipment. This is things that you could have direct line of sight on. Once again, very similar to an infrared camera. We want to be able to see what we're inspecting with an acoustic camera. Now, I'm sure everyone here is very, very familiar with infrared already, but because I do want to bring this into a holistic approach, just as those were specific places that we would like to use ultrasound, there are specific places that I would like to look and use an infrared camera, because I can tell you there are absolutely places I would recommend put down an ultra probe, put down an acoustic camera, and pick up a thermal camera. So for those of you that really aren't that familiar, either just from hands-on experience or not really using it in your facility yet, the biggest things we're looking for are the resistance issues. And typically the most common inspected points that we're looking for are loose connections, switches that aren't closed properly, overheating within a bushing or a transformer. So that's where we would use ultrasound and infrared together, but we're looking at two different things. Fuse clips are going to be a big one. I've seen a lot of early catches on fuse clips. Overheated switches. This is a perfect example of where ultrasound would not be able to inspect for, but infrared would instantly pick it up, is an unbalanced load coming to the plant. Now, there are always going to be tells within the facility itself if that's an issue, but infrared would always be the first option to check your lines coming in, see if you have unbalanced loads. Overload equipment, open circuits, inductive heating on other pieces of equipment. And then another one where I would like to use both technologies at the same time, going back to the transformers. While we're listening for the bushing and the camera, the infrared camera is also looking for overheat on the transformer, we could also see if there's an issue with the radiator, if the oil level is not where it should be, if it's unusually hot or cold in certain spots where it shouldn't be. And then a new one that's getting a lot of popularity is solar panels, being able to see issues with that. And then one that I don't think is done quite often enough, but is a huge benefit, is looking at defective insulators and lightning arresters. Hopefully you will never really need to have a lightning arrestor do its job properly, but definitely want to make sure that it actually is doing what it should. So now that we've looked at specific assets that would I use ultrasound for versus infrared and vice versa, when we're doing them together, there are very specific applications where it's a huge benefit. I've just listed out a few of them here. But as earlier, listening around the outside of a cabinet before we open it up, even if we're in the correct PPE, I don't think anyone wants to test the threshold of what that equipment can actually handle. And it's designed to keep you alive, not necessarily keep you comfortable if there is an event that happens. I would use both panels together, or both pieces of technology together, where there aren't windows. So once again, going back to a panel access. If there's not an IR window, then we absolutely have to use it. So identify what piece of equipment either are incapable of having windows put into them, or it's just not an available option at this time. Looking for outdoor equipment. Once again, looking for that corona. If we're outside inspecting a substation with infrared, I would pull ultrasound out to look for that corona event that might be happening, as well as very early stage faults that, due to solar loading, other factors, might be very hard to detect with an infrared camera. I'd look for both technologies together to be used during inspection for inductive heating issues with partial discharge. Really, because the process and principle of using these two different technologies go together so well, if you're using one, I would have the other available, because you never know when you're going to find an additional fault that might not have been missed by one technology versus the other. Because that inspection process is the same as far as sweeping, taking your time, making sure you're in the correct angle, correct distance. It really doesn't take hardly any time to put one down and pick up the other and do that subsequent inspection as well. So what we're doing when we do record those sound files, just to touch on this, is we're actually going to record that sound, like I said, at 20 seconds or so, and look through it through spectral analysis. So what we are doing is we're actually looking in two different forms. We're going to look at the event over time and then the frequencies that make up this sound. So what we're able to do is actually see the trends happening in the event or events occurring within the sample, to identify, like I said, corona, tracking, arcing, something mechanically loose. We can also look at the frequencies. What we're doing when we're breaking it into these two different forms is we're giving that sound a three-dimensional interpretation. So we can really be accurate on what is going on and look at the severity of it. So out of the events that we're looking for, the first one I'd like to go over is corona. So as a note, when we are looking for corona, that does occur on assets 1,000 volts or greater. So those are what I'll be starting off our inspection for. Typically, the higher the humidity, the greater your occurrence of corona. So times of greater humidity, early morning, would probably be the better time to inspect for it. Typically, where we see it the most is on high voltage outdoor equipment, but that is not exclusive. We've seen it occur on all sorts of different types of equipment, climate controlled indoor. So don't think that if you're not doing outdoor inspections, you don't need to look for corona. As long as it's 1,000 volts or greater, I would still recommend having this as something to be mindful of. So like I said, if you're not sure on this, we have a sound library on our website, or I can send you specific sound files that I've gathered. But the sound itself is very, very similar to an AM radio that's turned on but not on a station. So that static, crackling, fairly consistent sound. When we look at it, we, like I said, are going to look at it through FFT and time waveform. So the frequencies of the sound and the sound over time. Typically, we like to see that 60 hertz line frequency, so power distribution going out at 60 hertz. We should see, as in this left image, 60 hertz line frequency showing up consistently through. Not much content between all of them. And then on the event over time, typically we will see the discharge on the negative cycle, fairly even band height and spacing, and really not a whole lot of chatter or noise in between each discharge. So it's a fairly consistent, easy to read breakdown of that sound. Now, the next one that we look at is tracking. So typically, it can sound similar to corona, but it is much more aggressive. The most common way of describing it is going to be bacon and eggs in a pan, just lots of snaps and crackles. You still have that buzzing from corona, but it's much more aggressive. You do have snaps, cracks happening. Typically, what we see, especially as it becomes more and more severe, in that line frequency, it will eventually start to drop off. As in this left image, we have it continuing on, and then it starts to fade out. If we look at the event over time, we will have both positive and negative discharges, much more aggressive, uneven band heights, uneven spacing. It's just a much more aggressive image. So that's where, if you're not sure if it's corona or tracking that you're hearing, when we look at the event over time, it becomes very, very clear. The tracking is always going to be an aggressive sample in the event. Now, the most severe one that we look for, everyone's ideally never going to find, but it is out there, is arcing. So on that one, the frequency, if we do have the discharge, often we will see that 60 hertz line frequency is not necessarily, if you don't see 60 hertz, it's not arcing. You can still have that happen, but typically we would see a 60 hertz frequency on spikes, as in this left image. And then on the event over time, random abrupt discharges. So you can see that there is no build up to discharge, it just occurs. It is happening and then it immediately stops and then it starts up again. So probably the most aggressive sound that you would hear, very noticeable snaps and cracks, not much other noise going on unless you had other events occurring at the same time. And then out of all the events, probably the one that I run into more often than not when people are not sure what they're listening to is a mechanical issue. And that could be everything from, very benign, the nameplate on the cabinet is vibrating because there's only 3 screws, not 4. Or it could be something much more severe, like a wire rubbing on a bus bar or a bolt that's loose. There is some sort of mechanical event happening. Typically, this is where it is very, very important to look at the FFT and the time. In this example, we have what, if I hadn't broken down the analysis, could look like corona possibly, but we see that it is happening much faster than 60 hertz. It's actually a 30 hertz interval, and it could be faster or slower, but this is a tell that I'm not inclined to think that this is actually electrical in nature. And then when we actually look at it as the sample itself over time, this is a great indicator of something mechanically loose. So you see each one of these abrupt impacts, and I can tell that's an impact because it has almost this triangle arrowhead shape to it. So we're seeing the impact in the ring down of the event. So something is actually hitting another piece of equipment inside there. So very, very good example of mechanical impact. So now that we know, what we're looking for as far as generating reports, there's, at least in the UE world, there's 2 ways we can go about it. We can either use something like the cloud-based software for a camera, or we can use something more traditional like DMS to build out a report. Regardless of which platform you decide to use, there are things to consider when building a good report. Typically, we do want to make an assessment of what that partial discharge is. Hey, based on what I'm seeing, what I'm hearing, this is corona, this is tracking. It looks like we have arcing and mechanical looseness occurring at the same time. Absolutely include images of your assets, especially if you're discussing this with a team outside of whoever does your electrical inspections or maintenance, like outside the UNI team. You want to give them the reference of what you're talking about. Do include the voltage. Once again, while we don't need to have a certain minimum or maximum threshold to do ultrasonic inspections, knowing the voltage, especially when using like the AI software for the camera, will help us determine severity. So make sure you're aware of what your voltage is. If you can record it or measure it, the temperature and the humidity can make a big impact on the severity scale. I always try and include the sound file. If I can, give a visual breakdown of what I'm seeing, but then also include the original sound file itself. That can be a big game changer on getting more buy-in if you're having any sort of resistance on bringing an asset down outside of an outage or whatever it might be. if you have the right certification level, understanding of the analysis platform, or in the example of the AI software where it can actually do this for you, I would include the severity. So where the AI software comes in is it includes voltage, distance, type of equipment, and from there it can make a severity assessment as you see here on the screen. And then regardless of which platform you use, I would always include a recommendation, whether that's de-energize, further inspect, infrared inspection because we didn't have that equipment at the time, whatever it might be, I would have some sort of recommendation moving forward. An example of what that report could look like from that DMS software. So here, we're including all those points that, I like to see. The original sound file with what I'm actually seeing and an explanation of it, comments, suggested action, an actual original picture of the asset itself. And here we have the sound file also attached to it. So just a good inspection. The more information you give, the better informed people are, the better solutions you can provide. So now moving into some real world examples that we picked up, and I tried to limit it to some of the more engaging ones, but we have a pretty healthy library. So if you would like more than this, just please let us know. So first example is one of the smaller transformers. Like I said, perfect place for everyone to keep their lunchbox or toolbox or hard hat, whatever it might be. But in this example, we heard a sound coming from inside and was actually mechanical looseness. So we had all 4 bolts, the carriage bolts, loose. Now, once again, this is something that may or may not show up on infrared, but the design of it, without opening up the equipment and taking that paneling off and the housing off, probably would have been missed until we were at a critical failure point. So this is where using both technologies at the same time can be incredibly beneficial. And just a before and after what that sound file looks like. So this is on the left, what we heard out in the field coming from that piece of equipment. Repairs were done, visual inspection, reinspection. This is what we heard afterwards. That is ideally on the right, what we should always see inspecting energized equipment. An example from an acoustic camera. So once again, a before and after inspection. Beforehand, we had a target that was hanging out, absolutely did not want to go anywhere. Inspection was done. We came back and reinspected. The camera itself, like I said, will record. So we took the sound file, looked at it further ourselves. And this is a good example of seeing 2 events occurring at the same time. So we have 60 hertz line frequency. If it looks familiar to you on the left, that's that impact and ring down. Something's mechanically loose. But then we also see that discharge pattern, possibly tracking and arcing or just tracking at the same time. Definitely more than one thing happening at the same time, which the more information we can give to the team that's going to this equipment, the better they are at knowing what to look for. Now, granted, in this example, it was a pretty severe issue. We actually had one of the wires rubbing on the bus bar, and it had occurred for so long that it was starting to weld itself, basically. And this would have been a catastrophic failure. Now, this is one where infrared would have absolutely picked this up at this level, but ideally we would have caught this much earlier on when it was just the vibration, not the actual spot welding. And using both technologies together, so an acoustic camera and an infrared camera finding the same issue, verifying it, just one validating the other. Good example of using both at the same time. And what that sound file looked like from there. And then probably one of my favorite ones. A lot of the time through this, I've been saying, listen to the outside of a bucket before you open it for an infrared inspection. Well, here's where infrared could have possibly saved whoever was doing an ultrasound inspection from having a terrible day. Looking at that image on the right, that bucket is something I do not want to be standing anywhere close to. So that gives me the immediate caution of I don't want to close the distance to do an acoustic inspection of this while it's energized, because clearly there's a severe issue going on. So using both at the same time makes us a very, very safe inspection. And just to wrap it up, I know we're getting close on time, but biggest thing is know what you're working with, know the equipment, your own equipment, the assets you're inspecting, make sure you have the right tools, and that the people that are using those tools actually know how to use them properly, whether it's the software or the device out in the field. And one of the things, we're all great about sharing our successes. Hey, we found this, we avoided this outage, we avoided this failure. But I also recommend sharing, what you failed at. If you made a mistake and you had to go reinspect, let people know. that might be the reminder of, oh, I need to make sure that I do have these different components with me. I do need to make sure I record the sound file. That way I don't have to go back out. So I think personally sharing failures is almost as beneficial, if not as beneficial, as sharing your wins. And then it's an unending cycle. The better you get, the more you do, the better you get, the more you do, and it will keep building on itself. So with that, I do appreciate everyone's attention, and I would like to answer any questions that you have with the time that we have. Otherwise, I can follow up with them later as well.
Yeah, no, this was great. Thank you so much, John. And was able to answer a lot of people's questions in the chat, but just a couple that were kind of repeated themselves. So if it's something that was something you were thinking about, we did record this. We will put it up on YouTube. So just go to YouTube and just search UE Systems. Like I said, we've got a ton of great information up there. So check that out. If you want the sound files or anything like that, just take note of John's email address there. You can also get in touch with me. That's where all these the emails can come from to invited you to this to begin with. So either one of us, we can get you what you need. And then we were just curious for those that are still here, just so we're not bombarding the wrong people with, information. If you are interested in learning more and setting up, potentially like a Teams meeting where we can dive in a little bit more about your specific questions or what you're looking to do, or if you want to, get set up with a demo on site of the new acoustic imaging cameras or any of the things that John talked about today, just let us know, and then that way we won't bug you about that if you're not quite ready. But those that are, we want to be sure we get hooked up with you. And yeah, so that's great. But thanks again, John, and you guys know where to find us. And we're happy to talk about these topics and others, and look for us to do some more webinars here throughout the spring as we get ready for our Leading Reliability Conference. But yeah, thanks everybody for joining us. John, again, awesome information. Really appreciate you taking the time to share this with everybody. And with that, we'll let you guys go. Enjoy the rest of your day, and we'll catch you guys later.
Thank you, everyone.